goodness that wasn't on film. Oh, that would have been terrible. I'd be like, Miss Rice doesn't care about the well-being of her students. All right, we good? So the last problem in your notes had a nice triangle where it was a Pythagorean triple. So all the sides, 5, 12, 13, they were nice. There was no radicals. There was nothing to fix. This time, we got the hypotenuse at 15, and then the small leg at 4. So this long leg is not going to be nice. So we're going to go ahead and use the Pythagorean theorem to find the missing leg, and then we're going to talk about what's going to happen to all the sides when we work with it, because they're not all going to work out nicely. So when I use the Pythagorean theorem, I'm going to go ahead and call this x just so that we have a variable to put in the Pythagorean theorem when we work with this. Yeah. Okay. When we do the Pythagorean theorem here, what should we be writing? Okay. So this is what we have. What is 4 squared? 16. It's not the game you play in elementary school. No? Okay. All right. And then, before I just write the answer, what is 15 squared? 225. Nobody even laughed at my joke, so I'll just get rid of that one. We won't use it again. Okay. And then, what do I do to isolate the x squared? Okay, so 225 minus 16, 209. Oh. All right, 209. So x squared equals 209. I got confused because Kel told me the next step, so I started doing it already. Now, I'm going to write plus minus because whenever I'm the person doing the solving, we have to write plus minus. But this is the side length of a triangle. So I know that I'm not going to have the positive version and the negative version, even though that's the proper way to solve the equation. I know that I don't have two answers here. I only have the positive version, right? So I should write both technically because that's how we solve. But we do know that the correct answer is just positive square root 209. So failure to write the plus minus would be killing a baby horsey. We wouldn't want to kill a baby horsey, would we, James?
No, but
we wouldn't want to kill a baby horsey, would we, James? We wouldn't want to kill a baby horsey, would we, James? We wouldn't want it to look like we don't know how to do math. We wouldn't want to practice bad math now so that later we forget how to do it, would we, James? We would want to not do bad math in Miss Rice's presence, would we, James?
why would I say no? We just say no.
Court, I love how you're telling another student not to be difficult. Really? I'll believe that when I see it. All right, so the missing side is the positive version. We'll let James decide what he wants to do on the test. All right, so x equals the square root of 209. I did not kill a baby horsey because I like it when they stay alive. The freshmen are the ones who kill the baby horsies. That's why there's 20 dead ones sitting on the wall. Yeah, we're gonna try not to add to that tally because they were learning solving by taking square roots. And this is solving by taking square roots, and as you can imagine, they did a lot of not plus minus. There was a lot of killing baby horsies during that unit. All right. So, let's get started first with the theta. So, if the theta is the angle that we're looking at, the 4 is called what? What side is that going to be called? Opposite side. And the x is going to be called what? adjacent. And the 15 is always called what? Did anyone see the terrible SOH-CAH-TOA video that was going around on TikTok of the math teacher that probably got fired? I don't know if she did. In like Texas. Nobody saw it. So she, on the SOH-CAH-TOA day, that is, today for us, she put a headdress on and brightly colored pants. And she pretended that SOH-CAH-TOA was a Native American word. And then she danced around and made it sound Native American and made a fool of herself for like 10 minutes. And apparently this has been part of her lesson plan for a long time. And a student recorded it and put it on TikTok, as they should have. And then she was put on administrative leave from her job. As she should have been, because that is culturally insensitive. It was very cringeworthy to watch. We cannot watch it because I don't want to lose my job. I don't know. I watch, anyone want to guess what color she was? I don't know if I'm allowed to say that. Hold on, let me pause. All right, let's move on. Okay. Yes. Yes. Today's Thursday. Let's move on. All right, so it's gibberish. It's gibberish nonsense. He clearly did not. He clearly did not. Of course. SOH-CAH-TOA. Yeah, and just in case anyone was wondering, SOH-CAH-TOA is not a word in any language for any type of people group. It's not a word for anyone. Okay? Don't offend anyone later. It means nothing. It's gibberish. Okay? It just helps us to remember this. Okay? Please don't pretend that it's Native American. Please don't put a headdress on. Please. Okay. Okay. And if you do put a headdress on and somebody high-fives you in the face with a chair, you deserved it. Okay, let's move on. All right, sine. Sine is what? Anybody? Anybody? Opposite over hypotenuse. Wonderful. And thank goodness these are regular numbers, so we can just do it. So it's 4 over 15. Okay, we like that. And then which trig function is the reciprocal of sine? Which one is the opposite of sine? Cosecant. Perfect. So we're going to go right down here to cosecant. We're just going to flip that because this one's an easy one. Okay. Cos. What is cos? SOH-CAH-TOA. Adjacent over hypotenuse. Okay, so what is cos going to be? What's cos going to be? Root 2 over 9 over 15. Okay, so this one, since this one is root 2 over 9 over 15, and by the way, did you notice I didn't even ask you guys to simplify the square root? Did you guys notice that? They care about simplifying roots a lot in Math 2. It's a concept in Math 2 that you go over. In Math 3, they don't seem to care as much. Even on the EOC, they seem to leave roots unsimplified. Okay? So, do you still remember how to do it for Math 2? Hopefully, maybe a little bit. So, we'll go over it a little bit later on in this unit with some smaller numbers, but for the most part, they're okay with leaving them. They're even okay with leaving them sometimes in calculus. So, in calculus, sometimes they leave them, sometimes they don't. So we will practice sometimes leaving them. We will practice sometimes fixing them just to make sure it's a skill that you don't lose. But as far as the EOC goes, the EOC is completely calculator active. You never have to simplify a square root if you don't want to. Does that make sense? Okay. So for this case, you do not have to simplify the square roots on these. We do have to make sure we don't leave them on the bottom of a fraction, but you don't have to simplify them. Okay? Yes. Sure. Yeah. Oh, SOH-CAH-TOA. I like it. Okay. All right, so since cos is kind of nice, it's got the radical on top, that means that the reciprocal for it, the one that it goes with, is not going to be very nice. Which one does it go with? It goes with secant. Okay, so let's go down to secant. We're going to have to do some math to figure this one out. So let's go ahead and flip it. What's the flipped version? 15 over root 209. And so what I'm going to do, since I don't have room to write the final answer, I'm going to go ahead and do this math off to the side. So I'm going to go over here. I'm going to write 15 over root 209, and then we're going to reach all the way back to math 2, and we're going to remember how to rationalize. How do we rationalize? We don't want to leave the radical on the bottom, so we're going to multiply the problem by 1. Same thing on top and bottom, so we're multiplying it by 1. It's the same thing on the top and bottom. Anyone remember? Same thing as this radical. So we're going to do 209, 209. Ooh, I'm telling Miss Lopez on you guys. No faces there either. You're like, we don't care. You've learned this before. See, now I know because I'm teaching Math 2 right now, so now I know what's in Math 2. There's a whole unit on this, you guys. A whole unit. You guys are like, it's fine. Online doesn't mean you didn't learn it. All right, so, okay, so the top is 15 root 209. Okay, the bottom, what happens when you do root 209 times root 209? It's not 1. Wait. It's root 209 squared, which is just 209. Okay. So we're going to say that this answer became 15 root 209. Oh, I wrote that wrong. I'm almost out of eraser. 15 root 209 over 209. Miss Rice, that's a really ugly answer. I know. They tend to look ugly. Yeah, I don't like it either. All right. Okay. Now, we still have tan and cotangent, so let's do those two. Okay. Tan and cotangent. All right. So, TOA. We got tan. We got TOA. So, how do we write tan? Opposite over adjacent. So, we got 4 over root 209. Ugh, this is another gross one. Okay, but before we fix this one, let's do cotangent because it's the flipped version of this. So if this one is gross, that means that cotangent's going to be nice. When we flip it, it's going to be nice. Okay? So if tangent is 4 over root 209, then what's cotangent? Root 209 over 4. Okay, that's not so bad. So let's go ahead and take the tangent one and let's fix it. So I'm going to take this answer off to the side. So I got 4 over root 209. I'm going to fix it. I'm going to multiply it by 1. So, and now we're pros at this, right? So what goes in the radical? 209. Okay, and so on the top, what do we have? 4 root 209. And on the bottom, what do we have? 209. Okay. So I'm going to say that tan is 4 root 209 and then 209. Okay. All right, we're halfway done. Well, that was fun. Okay, so we just did it for theta. Now we got to do it for beta. Okay, let's do it for beta. All right, so the names are gonna switch a little bit. So the hypotenuse is gonna stay the hypotenuse, but now if we're talking about beta, is 4 still the opposite side? No. What is 4 now? I said is 4 still the opposite side? And Walker said no. And I said, what is 4? And Walker said opposite. That's good. I liked it. Okay, so 4 is adjacent. And then what is the root 209? Opposite. Okay. And then hypotenuse is still hypotenuse. Okay. All right. So we're still doing SOH-CAH-TOA. SOH-CAH-TOA. So sine of beta is what? Sine of beta is what? Wait. Sine of beta is root 209 over 15. Okay. So we got root 209 over 15. Okay. And then sine corresponds to what? Not cosine. It sounds like it is, but it doesn't. Cosecant. Okay, so we're going to take the root 209 over 15. We're going to flip it. That's 15 over root 209. And we've already done the work to fix this one. So I'm going to look at my work. It's right here. 15 root 209. Okay. All right, cos beta. What is cos beta? 4 over 15. Okay, cos beta is adjacent over hypotenuse, so that's 4 over 15. All right, and then what corresponds to cos? Secant, okay. So if cos is 4 over 15, then secant is 15 over 4, okay. And then tan of beta is what? It's opposite over adjacent, so it's going to be okay. And then for cotangent, we're going to flip it. And we've already fixed this one. So we know that that's 4 root 209 over 209. All right. How do your brains feel? Whew. Okay, so can you see that these, between having 2 different angles to refer to, these would be really easy to mix up. You guys notice that? So we've got to be careful when, especially when we first start learning this, to look at the angle that we're referring to and to label the sides that we're talking about: opposite side, adjacent side, hypotenuse side. Does that make sense? Okay. The boring practice, I want you to do that first because it's easier than the zombie assignment. And I think what I'm going to have you guys do, I think that I'm going to say, you guys want to do odds or evens? I don't think it really matters. I'll let you guys choose. You can do odds or evens. It doesn't matter to me. Okay, when you look at the assignment,